Good morning, dear students. Now, today we will see about the rules of the naming for the organic compounds. So, let us first see nomenclature rule books, how it existed. The first version of the nomenclature rules were represented in Blue Book. The name of the book is Blue Book by the scientist J.R. Gandy in 1979. In 1947, it was decided to give the names to the organic compounds by IUPAC, and the first version was prepared by J.R. Gandy in 1979. And then after, the updated version took a very long period, that is in 1993, and it was represented in the chemistry journal by the scientist W.H. Powell. IUPAC every year is publishing a chemistry journal in which whatever the change or whatever the new existence of the chemistry takes place is mentioned. So in this chemistry journal, which is updated in 1993 by W.H. Powell, about the rules of nomenclature for the organic compound is given, and whatever the rules we will discuss here in 11th standard, it is based on the chemistry journal by W.H. Powell in 1993. So yesterday, as I told, one common system, that is the trivial system. Before this all, the names were given according to the trivial system, that is a common system, as per the source from where the compounds were available or as per their test. But it was difficult to give the name throughout the countries in the nation, across the nations, that because for the similar or for the one compound, different countries were giving different names. And that's why now the second system existed as per the J.R. Gandy and W.H. Powell, that is the IUPAC system of naming organic compounds. As per the IUPAC, organic compounds are classified by given name. First is root word, the next is suffix, where primary suffix and secondary suffix takes place, and the third is prefix. So naming of the organic compound is classified in these three, that is root word, suffix and prefix, where root word, that is the word root, comes in the center. When the compound exists, the name is given, and the first word is the main word which is in the center, which is called root word. Root word is the naming which is given according to the number of carbons in the parent chain. Now when I say parent chain, then the parent chain is the longest chain present in the organic compound. Right? As we will proceed further, you will come to know what is the longest chain and what is the parent chain. Right? Now about the suffix, and it is also of two types, that is primary and secondary. Primary suffix is given as per the kind of carbon-carbon bonding, single bond, double bond or triple bonding. And secondary suffix is according to the present functional group in organic compound. Which functional group is present, according to that functional group, secondary suffix is taken. And prefix. Prefix are also in two types, that is as per the side chain present with the main carbon chain, or we can say the branch, that is the alkyne chain. And the next is as per the present substituent functional group. So in the last video, I have given 2-3 functional groups which are not main functional group. They are the attached functional group to the main functional group, like nitro compound, thio compound, that is SH, NO2, NH2 amine. Right? So such substituent functional groups are also taken as the prefix. Right? So when we will write, what will take place? In the center will be the root word, right? To its prefix, that is before it will be the prefix, that is alkyne chain, as well as the substituent, non-main group, functional group, and to the right of the root word, first will be the primary suffix as per the carbon-carbon bonding, and then the secondary suffix as per the main functional group, right? So see here, in middle it will be the root word to its prefix, that is the naming sequence, then primary suffix and then secondary suffix. Now first, root word. Root word are as per the number of carbon atoms in the center, right? So which we have come across in 10th standard. So what are these? Number of carbon atom and the root word. So if carbon atom 1, then root word will be meth, 2 eth, 3 prop, 4 but, 5 pent. These are the carbon atom. 6 hex, 7 hept, or sept also is written. 8 oct, 9 non, 10 dec. Right? Up to this stage, till 10 it's okay to learn. Then from 11 onwards, as we have learned in periodic table, more than 100 elements, when 111, 102, 103. For 1 we were using un, right? Unnil, yum, unnil by yum, unnil trium. So if it is 11, then it will be undec. If it is 12, then it is dodec. But mostly up to this stage, we will come across up to 10 carbon. More carbon also will be there, but we are supposed to consider the longest chain. So remember up to 10 carbon and its root word. Now comes the primary suffix, right? That means very next to the right of the root word. So primary suffix is as per the carbon-carbon bonding. If double bond, single bond and triple bond, then for single bond it will take ANE, alkane series, right? And see here an example I have given CH3, CH2, CH2, CH3. So for the root word, first of all we will see number of carbons 1, 2, 3, 4. 1, 2, 3, 4, single chain. So 4 carbon from either side. So but, then all is single bond. So it will be ane. So if we will join this center root word and its primary suffix, then it is butane. Right? But instead of single bond, if it is double bond, see here, then it will take ene instead of ANE. Now here it is ENE, alkene family. CH3, CH2, CH, double bond, CH2. So again 1, 2, 3, 4. Here double bond is on this side, so we will consider 1, 2, 3, 4. 4 carbon atoms and double bond, so it will be butene. And if triple bond, then the suffix will be YNE, that is ine, alkyne family, CH3, CH2, C, triple bond, CH. So 1, 2, 3, 4 carbon, triple bond. So it will be butane. Butane, butene, butane. Clear? So how we will give the names? This is the basic ideas which you have learned in 10th standard. But now we will learn in a deeper manner with all other rules also. Now the next is secondary suffix to the right of the primary suffix. It depends on the kind of functional group presence. Right? So first we will consider root word by the help of the carbon numbers, then primary suffix with the help of the number of bond present between the carbon-carbon, single, double, triple, and now secondary suffix which is based on the main functional groups, because substituent functional group will be taken as prefix. So our first functional group, suppose it is alcohol, that is OH group, then it is represented by the end OL, alcohol, whole spelling we will not take, so only last two word OL, alcohol, ol. See, let us see an example. CH3CH2OH. Now here, first root word, that means number of carbon atoms, 1, 2. So it will be eth, right? Then carbon-carbon single bond, so it will be ane. And now functional group is alcohol, so it will end with OL. So it will be ethanol, ETHANEOL. But E and O both are vowels, so they should not be taken together. So we will omit E and our final spelling will be ethanol, ETHANOL. Right? One more example. CH3, CH2, 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 CH2OH. Now what is our first method, or what we can say first step? Root word. So count the numbers of carbon. 1, 2, 3, 4, 5. So pent, right? Now all single bond. So ane, pentane. But here functional group OH is added. So it will be ending with the secondary suffix OL. So here it is pentanol. Now see here, CH2 double bond CHOH, right? So in this example, we have double bond and number of carbon atoms here 1 and 2. So it will be eth, right? Now double bond, so it won't take A and E, but it will be ene. So ethene. But secondary suffix will also take place, that is OH group. So it will be eth, ene, and OL. So it will be ethanol, right? Now let us see for the second functional group, that is aldehydes, CHO, right? Aldehydes are known as a terminating functional group. Terminating, it means they always present at the terminate. The terminus, that means either on this side or on the further side. That means on either of the two sides of the parent chain. Terminating functional group means always present at the terminals of the parent chain, not in the center. Thus, the terminal where the aldehyde is attached, that carbon atom of the parent chain will be the first one. Right? So, if it starts from the right hand side of the parent chain, if aldehyde group is on the right hand side, then the carbon number 1 will be considered from there. That means from where, on which side aldehyde group is there, that carbon is the first one. Right? You have seen in the movies a dialogue that जहाँ हम खड़े हो जाते हैं वहीं से नंबर शुरू होता है. So aldehyde is like this. Where it stands, from there the carbon number is given. Right? The name of suffix will be al. As alcohol was given OL, here it is aldehyde. So aldehyde starts here AL. Starting two word is considered as a al at the suffix. See example at CHO. So root word is based on the number of carbon atoms. So here carbon atom is 1 and single bond only. So it will be meth and ane. But aldehyde group is here. So that will be methanol. And one more thing we'll keep in mind. The carbon which is in the functional group CHO, aldehyde functional group, is along with the carbon. This carbon will be considered in the parent chain. Its common name is formaldehyde. Right? Formal, first, and aldehyde. Now second is CH3HO. Now see here, this side aldehyde group is there. So this carbon will be the carbon 1 and this is the carbon 2. Right? So two carbon atoms, it will be eth and single bond, so ethane. And CHO group is there. So we will consider is as ethanol, AL. The one more is CH2 double bond CH, CHO. aldehyde group on this side. So first carbon, second carbon, third carbon. Right? Why I am giving? Because when we will give the complete name, here it is just 1, 2, 3 carbon. So it is propane. Right? But double bond, so it is propene. Now aldehyde group, so propenal. Now complete rules when you will learn, then this name will be 1, 2. On second carbon double bond is there, so it will be 2 propenal. That means on second carbon double bond is there. So at last, after learning all the rules, we will come to know that what is the importance of knowing the functional groups, about their features and giving the numbers. The next group is ketone group. Its general formula is on either side alkyl group. In the center it is the C double bond O, right? The alkyl group may be same, they may be different. Ketones are non-terminal. They never comes on the terminal sides. Ketone is non-terminal function groups, means it will not be at the terminals. It will be at the center of the chain. Ketone functional group is applicable from the third carbon atoms. It means for less than 3 carbon atoms, ketone functional group is not applicable. For 1 carbon, for 2 carbon, it is not applicable. The smallest ketone starts from the 3 carbon atoms, that is propane family, propanone, right? So, the representation of the secondary suffix for the ketone group is with O and E. So, here we know that O and E is 1. But actually, the pronunciation which we will have to do is not 1, but it is O-N, O-W-N, own. Not O-N-E, 1. Right? So, let us see an example here. CH3, C double bond O. CH3. Either side alkyl group and center is the ketone C double bond O. So here 1, 2, 3. That means the carbon of the ketone group is also considered in the parent chain. So 3 carbon prop, carbon single bond. So it is ane. Don't mistaken yourself as it is double bond here. So it will be ene. No, this double bond is between carbon and oxygen, not between carbon and carbon. So ane and as ketone group, so ane will be taking secondary suffix as one. So 3 carbon prop and ketone group. So the name will be propanone. Prop, A-N-E-O-N. But again E and O, both vowels are together, so not taken. So we will have to skip E and it will be propanone. Right? The common name of the propanone is acetone, a chemical which is used in the nail polish remover. One more example is CH3, CO, CH2, CH3. Here, if CO is written in this manner, it is again C double bond only, because C and 1, 2, 3 carbon, hydrogen, so 1, 2, 3 and carbon. So 4 valency of carbon satisfied here. This carbon, one attachment here and one attachment to this carbon and double bond O. So if it is written in this manner, then also we will consider it the ketone group 1, 2, 3, 4 but. So it is butanol. The another functional group is carboxylic acids. Its formula is COOH. It is also a terminal functional group as aldehyde. It will be either on the left or on the right of the parent chain on the terminal position, that is the side position. Carbon numbers is given from the side where it is attached. So carbon of the carboxylic acid is also considered as one of the carbon atom of the parent chain. Its carbon is also considered in the parent chain. The suffix used is oic acid carboxylic acid, the suffix will take oic acid. See here, HCOOH, one carbon, so it is meth, and primary suffix is single bond, so N, and secondary suffix is carboxylic acid group, so it will take oic acid. So it will be methanoic. So here again E, O both vowels, so skip E, and it is our methanoic acid. The common name is formic acid. One more example is CH3COOH, C of the carboxylic acid, and one more C, so 1 and 2 carbon, so eth, single bond ane, and carboxylic acid group, that is oic acid. It will be ethanoic acid. The common name is acetic acid, and still in the market the ethanoic acid, acetic acid is called vinegar, which is added in the for the food preservatives, pickle preservatives, and widely used in making the Chinese food sour in taste, right? One more example, CH3CH2COOH. So carbon 1, 2, 3 carbon, so prop, single bond A, and acid group present, so it is propanoic acid, right? So this is all about the 4 functional groups we have seen today. And the next video we will see few more functional groups, and then the other rules which are needed for writing the single chain as well as branch chain and subsidiary chain on organic compounds. Thank you.